Hello and welcome. My name is Habib Haydarian, and I'm a program manager on the .NET platform team, which includes the .NET runtime, the .NET framework, as well as things like setup and servicing. It's been a truly historic week. There have been so many announcements around .NET, everything from Roslyn, the .NET Foundation, Azure Mobile Services, the Orleans project, and so forth. And so what I'd like to do in this session is share with you a very early roadmap on what is happening in the next generation of .NET. I really want to underscore the word early because this is a point in time, and I want to set the right level of expectation. Meaning, just because you don't see a topic on the slides or in the demos, it does not mean that we are not working on it or we don't plan to work on it. We are at the very stages of planning and development of the next version of .NET. In fact, I would say .NET VNext hasn't been even defined yet. So as part of our new approach to the open development process model that we're working through, we want to share with you this very early roadmap. And the reason why I'm here today is to share the roadmap, give you some extremely fresh bits. And what I mean fresh bits, I mean this is pre-alpha bits. And so in return, what I'd like to get your help on is feedback. We really need your feedback to help define what we should do next in .NET. All right. I think the best way to start this presentation is to talk about the current state of .NET. For those of you who remember, we rolled out .NET 4.5.1 around 4 months ago. And we made a very simple yet strong promise that .NET 4.5.1 will be one of the highest quality releases of .NET with very high compatibility bar. And I can tell you that as of this week, we have now installed .NET 4.5.1 on 500 million machines. Just think about that for a second. And what's truly impressive in my mind is the fact that out of the 500 million installations, we've literally seen a handful of compatibility issues. And I do mean a handful of compatibility issues. So my ask of you is, if you're using .NET 2.0, 3.5, 4.5, I urge you to upgrade to the latest version of .NET to reap all the benefits. And my commitment to you is, if you do run across any issues, we have a variety of channels, and I'll share that with you later on, where you can reach out to us and make sure that we help out with the issues that you're having. Now, let's move on and talk about the roadmap for the next generation of .NET. If you look at our set of investments, they really fall into 3 buckets. We're going to enable a set of brand new innovations around things like native code generation, things like a brand new just-in-time compiler, and also a set of new innovations that, in my humble opinion, truly move .NET into the future. And so the next set of things that we're going to also focus on is what is the set of customer feedback that we need to integrate to be able to make those investments a reality. The next set of things that we are focusing on is cross-platform. This is several efforts that is going on right now. And for those of you who were able to attend the keynote as well as watch Miguel's talk, you saw our close partnership with Xamarin in this space. And also, we are working on making sure that our libraries that are being released on NuGet are cross-plat by default. And then last but not least, this notion of openness. And when I say openness, I don't just mean open source. I mean openness in the way we communicate, in the way we release our documentation, and just in the way that we do business. And I'm going to, at the end, share with you a brand new experience that we're working on. It's still very early on, but I really do think that it gives an indication of where we're going with .NET as far as our open approach is concerned. OK. Let's start with the first sort of investments in the next generation of .NET. Just yesterday, we blogged about a new effort called .NET Native. And it's really about a new story around pre-compilation that offers the performance of C++ with the productivity of C#. And it really builds on the current generation of this compiler in the cloud effort that we started with Windows Phone 8, and it moves that to the next level. And what it means for developers is at least a couple of things. In the future, when you build device applications, regardless of whether if it's Store or whether if it's Windows Phone and perhaps other devices, the idea is that you have this beautiful, consistent API surface area that you can target all these devices. But more importantly, the true value also as far as .NET Native is concerned is that it provides a huge gain in performance in both application startup as well as reduced memory usage. And so what we've been doing is we've been working with a set of partners, Wordament, which is a very popular game in this store. And when they tried out .NET Native, they have seen some incredible gains as far as performance is concerned. Specifically, they've seen close to 40% gain in the cold startup time, and also a similar number as far as warm startup is concerned. Also, more importantly, they've also reduced the memory consumption by a double-digit factor. And so what I'd like to announce today is the fact that the developer preview is available today, and I'll go into more detail of what that actually looks like. If I were to double-click on .NET Native and explain a little bit of the internals, what you'll see is that it's essentially made of two components. A brand new runtime that is lean and refactored, and it knows how to load and execute native code, coupled with a compiler that is literally the same optimizing backend compiler that C++ has, that generates absolutely kick-ass fast code. And you'll see some of the results that we're working through as we speak. And what this means is, if you look at the productivity of C#, you get the same benefits as you do today. The debugger features, you get things like the consistent APIs, you get first-class developer experience. But one of the other things that you'll get is this simple packaging story. And the idea behind that is that because we basically link in, so to speak, the APIs that the application uses, you now have a single exe that doesn't require you to distribute the .NET framework as part of your application. The other thing is the fact that it's not right now, and it's because it's still alphabets. In the future, we're going to have complete integration with Windows Store as well as Windows Phone Store, so you can simply deploy your IL into the store, and then the compilation will happen in the cloud. As far as the performance of C++ is concerned, one of the side benefits of using the C++ backend optimizing compiler is the fact that because it generates native machine code, you now get natural obfuscation. Now, I'm not sure about the skill set of a lot of folks out there, but if you can essentially disassemble and decompile native code, then you can do the same thing with .NET Native going forward. But the bar has certainly been raised up orders of magnitude. And as I said, as you saw from the numbers on Wordament, we're seeing significantly faster app startup time, reduced app memory usage, as well as faster code execution due to these advanced optimizations. And I'll show you this amazing demo in my mind that really illustrates what that looks like. So the release that's available on MSDN as of yesterday allows you to build applications on both ARM as well as x64. And as I said, these are still more or less alphabets, and x86 is coming. We are working on it as we speak. And one of the things I want to highlight is the fact that V1 is targeted at store apps. The immediate question I'm sure at least half of you are thinking about right now is, well, what are you guys doing about desktop apps, WPF? Can I use .NET Native for things like WPF as well as ASP.NET websites? What I can tell you is we are looking at leveraging some of the same concepts and capabilities for other scenarios. But that is right now, as I said, we're at the very early stages. And our commitment right now is we are going to enable this at bare minimum for store applications. The proof is in the pudding. If you were to download these 5 applications from the store today on your Surface, you'll notice that every one of these is running on .NET Native. So now we have real-world applications. We've been working with tens and tens of partners, both inside and outside Microsoft, to really prove out .NET Native against real-world applications. So I'm very pleased to say that since .NET Native can enable some very large apps, then we are very certain that we're going to be successful in shipping .NET Native to the masses. What I'd like to do today is share with you the experience that you're going to see when you download the developer preview today. I want to underline the fact that this is still a developer preview, and therefore the experience that you see today may not be the experience that you'll see when we actually ship the product. But the steps are very, very simple. It's the same Windows Store application as you have today, and the idea is that it's a 2-step process. First of all, you simply enable .NET Native for your application, and then when you want to test/debug it, you actually have to now make it architecture specific. So in this case, as I said, we're supported for ARM as well as x64, and so you have to choose one of those platforms. Let me walk you through a demo of what the preview experience looks like. So here I have Visual Studio 2013 Update 2 RC. This is the bits that are available this week. And I have a very simple Windows Store application. And so I'm going to run the app as is. This is not .NET Native code. And what you'll see is exactly what you expect today. You will see in the modules window that you have the usual suspects, as well as the .NET assemblies are concerned, you've loaded. And then you can simply look at things like your locals and your autos window to dig through the various variables. Now, the next step is if I want to now optimize this application. So I've been developing this app for a while, and I want to now optimize it and upload it to the store. I simply go ahead and right-click on my project, and then there's a new option now called Enable for .NET Native. Once I've done that, 2 things happen. Again, I want to underscore the fact that this is just a preview experience to make sure that we can hand-hold you through the experience. First thing that you saw is this nice kind of hello world documentation that walks you through the bare minimum steps of using .NET Native. And the other thing that we've done is we've generated this really nice report. This report is really essentially our ask of you that if you come across any issues with .NET Native, please send us your feedback through the form. You don't need to go to a different website. You don't need to go to different forums. Everything is basically self-contained. Once I've done the enabling, the next step is to essentially now enable the compiler toolchain. And there's an option on your build property page called Compile with .NET Native Toolchain. Once I've done that, I'm going to build it. And the first thing that you notice is this. There's this message that says several compilation stages will occur. This may take up to several minutes. Now, why do we have this message? I think one of the things that you're all familiar with today is that with the C# compilation model, everything happens very, very fast. With .NET Native, we go through several compilation models, and as I said, at the end, we actually use the exact C++ compiler as Visual C++ provides. So what happens is we take the output of the C# compiler, which is IL. We essentially then remove the unused dependencies from that IL. Then we take that IL and more or less hand it off to the C++ backend compiler, which then optimizes the heck out of that IL and then generates native machine-dependent code. So you can see right now, we even for this, again, this is just a double preview, we even tell you how long it takes to go and build the application. Once I've done that, I'm going to start the debugger again, and notice the difference right here. At first, you might say, well, this is not different at all, but let's actually go through this now. If you look at the modules window, notice something very interesting. Even though the modules are shown in the modules window, the actual path itself, it's showing that it's now embedded within the single binary. As I said, this is the simplified deployment model. But what's really nice about it is that because we still want to have the first-class support in Visual Studio, we didn't just simply go and hide those modules because they're no longer being loaded. We want to make sure that as developers, you're still aware of what dependencies your application has. But what's also important is, despite the fact that this is now native x64 code, you can debug this code just as you would with .NET managed code. So it's really, really important to underscore this, is that we want to make sure that despite the fact that this is exactly C++ code that's actually running right now, you can debug it just like you do your C# code, which is I think, a great benefit that you typically don't see when something goes from essentially IL down to x86 instructions. Okay. Now you ask, great, you guys are using the optimizing C++ backend. What does it actually get you? What I can tell you is there are some amazing scenarios that open up to .NET developers because now we are using the optimizing C++ backend. And one of them, this is just one optimization that we are currently working on, and you're actually going to see a video of it because it's not even ready yet, is the fact that the C++ optimizing backend can now do things like essentially vectorize and automatically parallelize your application without you doing a single thing to your code. So the demo that I'm going to show you shows you 3 stages. One is your scalar code. There is no parallelization in this code at all. The next phase that you're going to see is the fact that the code is now vectorized but on a single core. And the last phase is the compiler will then take that code and vectorize it and parallelize it across as many cores as there are available on the machine. So let me switch back to the demo machine and show you what this looks like. So this is your .NET code today without any optimizations. Next, the same .NET code gets vectorized, and look at just what happens when the C++ compiler now takes that code and then vectorizes and parallelizes it. The performance difference is incredible, right? Imagine now you're a game developer or you're doing CPU-intensive operations where the compiler will just take care of it without you doing a single thing to your application. So this is the exact method that does the simulation. And if you look at the code, the for loop that I've emphasized there, the most remarkable thing about that for loop is what you don't see. What you don't see is a special markup or special syntax that instructs the compiler to optimize the code. What you don't see is p invokes to C++ calls. This is just vanilla C# code that the .NET native takes and optimizes it and makes your application that much faster. And And I think this is a tremendous improvement where now you get the performance boost of C++ that hasn't been available to C# developers since the inception of .NET. Okay, so the call to action as far as .NET Native is concerned is this. I'm sure right now you're sitting in the audience and you have a bunch of questions going through your mind. What we've done is, in fact, I can show you right now. We knew these questions were coming, so we've created a .NET Native website that has both the downloads, the documentation, and then we have an in-depth video that describes what .NET Native is, thanks to Sean, who's sitting right next to me, who is the dev lead for .NET Native. But also, the other thing that we've done is this. We know that there are a bunch of frequently asked questions around .NET Native. And I'm sure, as I said, most of you are asking yourselves, scenario A, scenario B, and so forth. We've done our best to capture every single one of those questions. But in case we haven't, we actually have now a forum set up for .NET Native where you can ask your additional questions around scenarios, as I said, or special cases that you have questions around. So just to reiterate, .NET Native requires Visual Studio 2013 Update 2 RC. If you do want to ask additional questions, we're more than happy to answer those at our booth. And as I said, we are sharing with you a very early roadmap of .NET. And please, we would love to get your feedback on .NET Native and how we can make it better. We even have set up an email address where you can send us direct mail where we can respond to. OK, while we're on the subject of code generation, some of you may be wondering, well, what about existing WPF applications? What about existing ASP.NET applications? And so what we've done is we've also made a lot of investments in the next version of .NET to essentially take the .NET code generation to the next level. And so this is the workflow today as far as code generation is concerned. You take C# code, you compile it down to IL, and then the just-in-time compiler takes that and then basically converts that into machine code. And so we've made a lot of investment in the last step where we've now introducing a brand new just-in-time compiler, which we've codenamed RioJIT. It's written from scratch. And the value proposition for the next generation just-in-time compiler is extremely simple. It makes your existing WPF and ASP.NET apps better. By better, I mean faster startup time and fast execution time in a lot of scenarios. And I think the easiest way, perhaps, to show you what that looks like is I'm going to switch over to another demo machine. As I said, these are still pre-alpha bits to show you what that experience looks like. Here I have a WPF application. And on the left-hand side, what you'll see is the WPF application using the existing just-in-time compiler. And the right-hand side, which is denoted by RioJIT is the same application running on RioJIT. And it's a very simple WPF application that basically parses regex expressions. And so what I'm going to do right now is click Do It on both of these applications. I'm going to click Do It first on the app that is running on the current JIT. And then I'm going to do it that is running on the RioJIT. And notice something. This completed in about 3-something seconds. What you'll notice is this code will sit there for many, many, many seconds trying to compile. And I did not have to make a single change to my application to be able to take advantage of RioJIT. And so by just using RioJIT now, I've dramatically improved the performance of my application, both in terms of startup time and code execution time. So how does the magic of the next generation of the JIT compiler work? There are really 4 things about the RioJIT to keep in mind. The improvements that we made were in 4 areas. Throughput, which means how fast does the compiler or the just-in-time compiler generate code. Code quality, meaning what is the quality of the code that's generated and how fast does that run. Consistency. With consistency, the idea is that across the different architectures, how does the same just-in-time compiler perform? And last but not least, predictability. How do the various metrics, so to speak, change depending on what the type of application is? But I think one of the most exciting things about things like RioJIT isn't that it just makes your existing WPF and ASP.NET applications better, but it also is what we call our new innovation platforms, the platform. So I'm going to show you one example of that called SIMD, but there are a number of other new optimizations, innovations that are coming up in RioJIT where we can really move the ball forward. The one thing that I do want to mention is that RioJIT is available for x86 today, and you can go and download it, and we'll have all the instructions towards the end of the slide. Very similar to .NET Native, we really need your input and your help. So we have a number of resources out there that describe in detail what RioJIT is. You can download RioJIT, and also you can contact us directly if you have any questions around RioJIT. At this point, you may be wondering, where is code generation in .NET going? Are you guys doing static compilation? Are you doing dynamic compilation? Are you investing in one or the other? And the answer is this. We are actually moving the ball forward in both directions. What I mean by that is there are literally hundreds of thousands of .NET applications out there with different workloads and with different requirements. And we want to be the best of breed compiler in both static and dynamic because we understand clearly that it's a continuum. We have customers that are doing highly dynamic scenarios. Hosting code is a great example of that. And we have folks that want to be able to, in the future to run .NET on the tiniest of devices. And that is where things like .NET Native really comes into play, where performance becomes such a critical element of making this scenario pop. So if you look at our roadmap, we are going to move both static and dynamic compilation forward. In dynamic, we've had the optimizing JIT for many, many years. We are rewriting all that and creating a new architecture as well as a set of new optimizations with RioJIT. On the static part, we've kind of taken several steps. For those of you, I'm sure many of you are well aware of Engine, that has been there since pretty much day 0, which is all about on-device static compilation, where we take the IL and then, as a separate process, we turn that into machine instructions at deployment time. Then we took that and we went with a hybrid model for Windows Phone 8. What I mean by that is we did most of the compilation in the cloud, and what happened is when the user downloaded the Windows Phone 8 app locally, we did a simple binding step towards the end, but it still was a hybrid model. With .NET Native, we are going all the way in, meaning as our cloud compilation model, which is optimized for static compilation, the scenario for device development is you build, you edit, you compile your application and debug it locally on your machine, and then you deploy MSIL to the store. Then the .NET Native compiler runs in the store, pre-compiles your application for the specific architectures, and when the user downloads the application, they get a nicely packaged binary that is automatically compiled. So the first user experience is so much better as far as devices are concerned. Okay. One of the things I alluded to was, now that we have a new JIT compiler in place, we can do some pretty cool things. One of those things is a optimization or set of optimizations, I should say, around something called SIMD. SIMD stands for Single Instruction Multiple Data. And it is one of the top-rated features on user voice with about 2,000 votes. And what it does is that it enables essentially data parallelism in .NET. It's a great boost for computationally intensive workloads, things like games, things like scientific analysis, as well as financial analysis as well, but also for any type of code. And I'll show you specifically what it looks like. And the way it's exposed, it's a NuGet library that you'll be able to download today, and you'll be able to use the SIMD libraries on .NET today as part of the Ryujit CTP3 that I just talked about a second ago. I don't have a background in mathematics, so I'm not going to sit here and explain to you all the details of SIMD. But I really like the diagram that you see on your right-hand side, which is a very simple explanation of what SIMD is and how it works. Typically, in SISD, which is single instruction, single data, you basically have a single instruction working on a single stream of data. With SIMD, which is the diagram towards your far right, the idea is that you have the same instruction working on multiple streams of data. And what that does is it enables much, much faster code execution. And so I think the best way to actually see this work is via a demo. Let me change to the other machine. Excellent. And because watching me type is a dreadful experience, I'm going to be extremely lazy and spare you the pain. OK. The machine that you're seeing on your screens right now is a Lenovo Yoga that's powered by an Intel Haswell processor. The processor has both SSE2 instruction support as well as AVX instruction support. And I'll go a little more detail of what those things are in a second. But let me show you what the huge difference is when you take advantage of SIMD in .NET. OK. I'm going to run the application. And for those of you who are familiar with the Mandelbrot problem, this is a classic Mandelbrot application. And what we're going to do right now is we're going to fly through a Mandelbrot set without SIMD. This is just your everyday .NET code that you run today. And one thing you notice is this. It's extremely choppy, extremely sluggish. And one of the things that you notice on the bottom hand of the screen is the number of elapsed seconds. And so this should take upwards up to, I think, 25, 26 seconds to basically fly through this Mandelbrot set. And we should be there in just a second. So imagine if you were doing a similar computation in your application, it would not be a very good user experience. That's an understatement, by the way. And so once this is done, what I'm going to do is I'm going to now enable SIMD with the SSE2 instruction set. And so contrast the first version, which took about 25, 26 seconds. Let's look at now how long it takes with SIMD on SSE2. So let's go and click begin. It's much faster. In fact, it's going to complete in somewhere around 10 to 11 seconds. But still, the experience is not that great. It's about 10 seconds less. So I'm going to now close this application and then open the same application now with SIMD with AVX support. And so let's see what the difference is. It's buttery smooth. Notice that we went from 26 seconds down to around 5 seconds for the exact same application, right? Imagine that now. And by the way, this is just an existing WPF application, right? With SIMD in the next generation of .NET, you can take advantage of the same libraries in your ASP.NET code or your WPF code. So there is nothing specific that would exclude you from doing that. Okay, just a quick recap. What you saw was, by the way, the graphs, lower is better. The purple was essentially scalar. The blue was SIMD with SSE2 instruction support. And the green was SIMD with AVX support. So in summary, what we're seeing right now is this. With SIMD for .NET, we'll support, as I said, both SSE2 instructions and AVX instructions. And for SSE2, we are seeing up to 4x improvements in the application. And with AVX, we're seeing up to 8x improvements in the application performance. And as I said, it's available today as part of the Ryujit runtime as a separate download, NuGet download. So how is this API exposed? Once you download Ryujit, you simply go and download the Microsoft.bcl.simd NuGet package. And once you do that, you notice that there is a new type, a struct, vector of t, that has a bunch of properties and so forth. And one of the things that you'll notice as you play around is the fact that the length is fixed, meaning depending on the instruction set. For example, SSE2 is 128-bit, and AVX is 256-bit, and it's hardware dependent in this case. And that's why you saw the big performance difference between SSE2 versus AVX support. And I think the easiest way to see how you can utilize SIMD in your application is through essentially a hello world example. What you see here is a very simple loop that is not vectorized, that simply adds one value at a time. And you can clearly see that by this code example. The same code using SIMD looks a little bit different. By using the vector type now, you can now add multiple values simultaneously. So if you have a computationally intensive workload, the Ryujit runtime in combination with the processor will take care of all the heavy lifting for you, and therefore you're going to see massive performance improvements in your application. As far as the roadmap for SIMD is concerned, as I said, it is still a CTP. It's not even alpha. So we are sure that when you play around with it, you're going to find a bunch of bugs. You're going to see things that may not make sense, and therefore we need your help again to help us make it better. And the demo that you saw was both support for SSE2. So when you do download the NuGet package today, there's only support for SSE2. Our goal is with the next update of Ryujit as well as the NuGet package, we're also going to add AVX. I did mention to you that these are extremely early bits, so we still have a plethora of work to do to get there. And the other thing is we are extremely nowadays vocal about the work that we're doing. So if you want to see the latest and greatest about what's happening with SIMD and Ryujit, our blog contains a lot of details. In fact, just a few hours ago, we blogged on these features and others. Okay. So far, we've spent a good amount of time talking about the investments in the runtime side of .NET. I want to switch gears a little bit and focus on the framework side of .NET. The framework includes the set of libraries and NuGet packages that essentially provide you the APIs. One of the promises of .NET from day zero has been the fact that you can leverage the same code and also the same skill set to develop applications for a variety of workloads. So it doesn't matter if you're building a WinForm app, WPF app, ASP.NET app. It's the same skill set. It's a lot of the same code. So you get to leverage that to continue to advance your application. We are even more committing to making .NET productive and more consistent. And what I mean by that is, for example, if you are building a store application today, you've noticed that some of the APIs might be missing. We are going to do a much better job in the next version of .NET to expand the surface area so that the APIs that you know and love are also available in store applications. But also, we're going to go one step even further. When it comes to cross-platform, we really want to make cross-plat first-class citizen in .NET. So you're going to see a lot of our NuGet packages now be cross-plat by default. And more importantly, with efforts such as universal projects and this notion of one class library, we're going to make it even easier to leverage the same code across different devices and application types. And last but not least, if you have been following our NuGet feed, we've been very, very open with where our library efforts are going. In fact, on a regular basis, we are releasing both new libraries and updates to existing libraries on NuGet. And we have this very close relationship with developers out there that are providing us with real-time feedback that we have real people sitting at the other end and taking that feedback and releasing improvements based on that feedback. And more importantly, and this is the first attempt right now, we are using essentially, as soon as we have something to say, we say it. And that's why I'm here today. 3 years ago, I'm pretty sure this would have never happened. I would not be standing here and telling you what's happening with .NET because this stuff's not even half-baked yet, right? But I am here to show you what this point-in-time roadmap looks like right now so you guys can give us feedback to improve the next version of .NET and be part of the feedback process. We are doubling down on portable class libraries. So one of the biggest complaints that we received is, why isn't PCL available in Visual Studio Express? And I'm here to announce that in VS 2013 Express, a PCL will be available now. So for those of you who've been asking that, the other work that we've done is, as part of the convergence, as well as expansion of our surface area, the next version of .NET will also, actually the current version, what I mean by the current version is the version of PCL that we released in Visual Studio 2013 Update 2 does support Windows Phone 8.1 as well. And what this means is you can now really use portable class libraries to do binary sharing without having to go through the typical sort of hassles of sharing code between your various project types. Okay, let me share with you a very brief demo on the notion of one class library. Excuse me, I hit the wrong button. Okay. So what I have here is the same application, just a different reincarnation. It's the Cookbook app. It's currently a Windows Store application. And what you notice is it has a Windows 8.1 specific library. What I really would like to do is I want to now add essentially a Windows Phone 8.1 app to my solution. And I want to be able to leverage the same set of functionality that's available in this library. So let me go ahead, right-click on my solution, and say Add New Project. And let's call this, I don't know, Cookbook Windows Phone. And click OK. And this will do the usual thing of adding the new project. And through the magic of demos, let me go and drag and drop some files onto the Windows Phone app that I just created. I'm going to replace all the items because the point of the demo isn't necessarily what the app actually looks like. OK, so once I've done that, I really would like to make use of this library. Let's see what the experience looks like without support for Windows Phone 8.1. If I try and right-click on my add reference and then say add support to Cookbook Helper, what you notice is I can't do it because the library right now is a Windows 8.1 specific library. To actually get around that problem, I can right-click on the library, go to Properties, and then change support so now we can add Windows Phone 8.1 as well. Once I've done that, I'll go back to the Windows Phone project and add a reference to the portable class library. And notice something that happened. The library that was Windows Store 8.1 specific is now automatically become portable. So now I can use it from both my Windows Phone 8.1 application and my Windows 8.1 application. And so what I can do now is simply go ahead and build my solution and then run the same application if I want to. And so think about what you would do otherwise. If you didn't have this capability, you'd have to go and recreate the class library project, and then you have to add a bunch of references, and essentially you have to go through all this hassle. But now, with a couple of clicks, you can easily add support for Windows Phone 8.1 as well as Windows 8.1 stores. One thing I do want to point out is with the new version of portable class libraries, we now have also added support for Windows RT. So what that means is, and here's an example where we are actually using APIs from Windows Store in our portable class library to be able to share logic between both the Windows Store as well as Windows Phone Store. But you can also now share essentially XAML UI as part of your portable class library. So it's, you're no longer tied down to just business logic. OK. At the beginning of the presentation, I mentioned something about openness. And I know many of you were at the keynote this morning where it was announced that the .NET Foundation is now available, and many projects are contributing to it. What I want to emphasize is that when I talk about openness, I don't just mean open source. So if you look at what's happening with our MVPs and our insiders, we are literally sharing all our plans with them all the time. So they're giving us feedback early and often in every single thing that we're doing as far as the future is concerned. We are actively engaged with both customers who are individuals as well as very large businesses. And we also have a very, very active blog right now. In fact, we're seeing around 170,000 unique visitors to our blog on a per month basis. As far as source code is concerned, a lot of the ASP.NET NuGet libraries are now open source, but we also really refreshed our .NET reference source effort. And then, as I mentioned before, through our collaboration and partnership with Xamarin, we are going to extend the platform consistency and portability so that if you want to use .NET on other platforms such as Android or iOS, you can use the same sort of tools, same sort of APIs across the gamut of the applications. And also, we've made sure that when it comes to our licensing for portable class libraries, you are no longer just restricted to one platform, but you can use the same portable class library across different platforms. And through all this, I can tell you that about a year ago, we really focused on delivering our libraries out of band. And we're seeing tremendous uptake as far as NuGet is concerned. In fact, there are now upwards of 900 Microsoft NuGet packages out there, and we've seen up to about 58 million downloads across the .NET framework, ASP.NET, and also a number of other libraries across Microsoft. So this is where it's at, folks. A lot of the libraries where previously it would take us 3 years to ship, now it's taking us in the order of months to ship. And because we're making these things cross-platform, we're making them open source, and we're also, in a lot of areas, making them .NET version independent. That means you can use those libraries in a lot of different versions of .NET. In fact, if part of the metadata that's associated with the NuGet package will tell you exactly which versions of .NET the library is compatible with. The other number that I want to share with you is this. We are seeing a serious adoption across a number of NuGet packages, both the ones that are produced by Microsoft and also the ones that are produced by third parties. One thing I really want to underline is that even though we are releasing these libraries out of band, you still get the same level of support as you do with the existing APIs that are kind of shipped in the box, so to speak. So there is no difference. The main difference here is that we are releasing it much more frequently, and the feedback is much more open, and you can give us feedback at any time that you want to. Now, this morning, I am sure you all you all saw this slide where we announced the .NET Foundation, which I believe is a titanic shift in how .NET is going to progress going forward. There is a tremendous amount of potential here, folks. But I would say what I'm really most excited about is what things like the .NET Reference Source and .NET Foundation enable. We've been working on this little project that I like to label as source code as documentation. These are very, very fresh bits, folks. So let me switch over to my demo laptop. So let's say you have your favorite. Oh, well, I should be more careful of when I click in there. Is there anything offensive? No? OK. Thank goodness for that. Let's say you've now pulled up your favorite search engine. Mine is Bing, of course. And let's say now you want to search for a type to get help on in your search engine. So I don't know. Let's go with ArrayList in C#. And of course, it's the first item at the top of your search results. And I'll go there. It has, it's been like this for the last umpteen years. I can look at the types. I can look at things like the properties, the methods, and pretty much everything else as well. And I can click on one of these things and then find out more information and so forth. But wouldn't it be nice if I could, instead of doing all that clicking, actually go to the source code for the code? And folks, the thing that I love about this is that this is basically the ground truth, right? If you want to know what an API is, how it works, you can now search for it. As I said, this is very early on. If you were to go and search for your favorite type, you might not see it. But for things like string, array list, and the usual suspects, we have something up there as we speak. But also what's really nice in my mind is rather than having to read through help docs now, I can just look at these types and also see what's in there by just looking at everything that's available to me. And I think that is a fundamental shift again. If you remember, I talked about openness. And we are also approaching our documentation in a completely different way, where you no longer have to read through reams and reams of text, and the ground truth is right there in front of you in case you want to delve deeper in each one of those. I think there's a tremendous amount of potential here, and we're going to mine everything that we can here to make the experience that much better. Okay, just a couple more slides to go, and hopefully we'll have at least a couple of minutes to open up to Q&A. As I mentioned at the beginning of this presentation, I wanted to share with you a very early roadmap of the next generation of .NET. And we covered 5 different things, and I want to briefly tell you where we are with each one of those things. And also, I really want to underscore the fact that just because you did not see something in today's slides does not mean that we are not working on it or we don't plan to work on it. As I said, the next gen of .NET hasn't even been defined yet. I can share with you what we are working on right now, and what I can promise you is there's a lot more to come. So where we are with each one of our efforts is this. With .NET Native, it's supported for both ARM and x64. x86 is coming. Auto-vectorization, this is the body simulation demo, is also coming. And also we're exploring additional scenarios for .NET Native, which hopefully we'll be able to share a lot more information about later on. As far as the next generation just-in-time compiler is concerned, x64 is available today as a developer preview, and support for additional architectures is coming. When it comes to SIMD, support for SSE2 is available today as a developer preview, and AVX support is coming. As far as cross-plat is concerned, we are going to really focus on our partnership with Xamarin, and hopefully you'll even see more good news come out of that in the future. But also, we're really going to drive home this point of making NuGet packages cross-platform. In fact, one of the things that is happening I can share with you is we are partnering with Xamarin to make sure that our NuGet libraries are tested by Xamarin. And the way we've done that is we've actually given our test suite to Xamarin, who are using the exact same test suite to make sure that .NET is compatible across the different architectures. And as far as the ecosystem is concerned, NuGet is the mechanism that we're going to deliver APIs and libraries. And you saw a first glimpse of the capabilities that we can enable as far as the reference source and documentation is concerned. But there's a huge amount of stuff that's still coming. Now, here's my ask of you. There is a lot of things that I shared with you today. And the call to action is please try out Develop Preview and give us feedback. As I said, we are listening. There is at least 134 of us back in Redmond that are eagerly waiting to hear from you and your thoughts around what you think of our plans, what you think of the features, what you think of the scenarios. But I want to leave you with the fact that stay tuned. This is just a point in time. We still have a lot of time left on the clock, and we're going to be sharing with you a lot more about what's coming up in the next version of .NET as we solidify our plans. At the beginning of the presentation, I mentioned that we've really amped up our channels to listening. So it doesn't matter what your favorite channel is, whether if it's Facebook, blogs, direct email, please reach out to us. And I'm sure you get access to all these slides so you can reach us any way that you'd like to. So far, I can tell you, we've addressed the top 6 most voted user voice items, and we're going to continue to listen to everyone to make sure that we go after the highest priority items. And with that, I'd like to thank you all for coming, and hopefully you have a pleasant rest of build. Thank you.